Hey everyone, this is a video for week 9 Desmos activity for my Algebra 1B class. The goal of this Desmos activity is to get really good at identifying linear patterns. Let me get my pen going here. You're going to be working with linear patterns, quadratic patterns, and exponential patterns, understanding what is similar, but also understanding how they're significantly different. We'll be looking at tables. We'll be looking at equations, and we'll be looking at graphs. So just kind of comparing, contrasting. We did a lot of linear stuff the first half of first semester. We've done a lot of quadratic and exponential stuff in the second semester. So here we go. We'll kind of get you started on this activity and make sure you're understanding what's going on. The first thing come across, slide number 1. What type of function will fit these data points? So let me see what I've got going on here. Well, I'm starting with 3, and I might even make a quick little graph here. I'm going from -2 and then up 3. So I have a point like that. Then I have a -1, 0. So -1 is 0. There's a point there. Then I have when x is 0, y is -1. So that's a point right here. And when x is 1, y is back to 0. Well, notice right here I'm decreasing, but then all of a sudden I do a turnaround from -1 to 0 is increasing right there. Well, exponential functions don't do that. Linear functions don't do that. This is an example of a quadratic equation. And when you graph it, you can really easily see, oh yeah, might be something going on in terms of a parabola just like that. So what do we have here? We have ourselves a quadratic. The other way you can tell it's a quadratic in a table is by taking the differences. So start subtracting. 0 minus 3 means I'm losing 3 right there. From there I'm losing 1. 0 to -1 is subtract 1. But from -1 to 0, if I subtract 0 minus -1, that's an increase of 1. But with quadratic equations, notice they're not all the same yet, but with quadratics, if I take the difference again, they'll be the same. So from -3 to -1, that's going to be an increase of 2. From -1 to 1, that's an increase of 2. And quadratic, your second differences will also be the same. So we just showed with the parabola, we just showed by graphing. We looked at the fact that it decreased and increased, and we found our second differences. This is definitely a quadratic. All right, let's take a look at some other stuff here. What type of function will fit these points? This one's a little bit more obvious to see, but I'm going from 5 to 7, that's plus 2, 7 to 9, plus 2, 9 to 11, plus 2, 11 to 13, plus 2. The first set of differences is the same. If I would graph these, it's a nice steady linear equation with a slope of 2. If I wanted to put it into an equation, my y-intercept is 7. So an actual equation for this graph would be y equals 2 times x, because we're always adding 2 over and over again, plus 7. There's my y-intercept. So that's a lot of review of what we did in the first half of the year. There you go. We got a linear function right there. Table 3. What kind of function will fit this data? Well, let's see what we got here. So from 4 to 6, that's adding 2. From 6 to 9, that's adding 3. And from 9 to 13.5, that's adding 4.5. Already, it's not a constant pattern of adding, so it's not linear. Let's see if it's quadratic by finding the second differences. So from 2 to 3, that's plus 1. From 3 to 4.5, that's plus 1.5. These are not the same. If it was quadratic, the second differences would be the same. So it's not quadratic. I'm thinking that I may have to check if it's exponential. Remember, the pattern with exponential equations is It's a multiplication pattern. So we divide to see what we're multiplying by. What's 6 divided by 4? Well, that equals 1.5. What's 9 divided by 6? That's also, well, that equals 1.5. And what's 13.5 divided by 9? That, surprisingly enough, equals 1.5. So we have what's called the common ratio in mathematics. We are ratio, repeatedly multiplying by 1.5 over and over again. If I wanted to write an exponential function, if you remember exponential functions, we find our y-intercept, that's our starting value. So we y equals, we're starting at 9. What's the pattern? We multiply by 1.5 over and over again. So it's to the x power. So there would be an exponential function. So that's what you're going to do. You're going to be graphing, you're going to be looking at patterns and tables, you're going to be writing equations, comparing equations, and just getting really good at understanding linear, quadratic, and exponential equations. Let me know if you have any questions as you're working through this week's Desmos activity.